All right, repeated roots. So here we are with a second order constant coefficient linear homogeneous ODE, and we want to know what is the general solution to it, okay? Now remember, the template is literally the same for all of these. It really just depends on the solution type. Check out the video on the different types of roots and solution types and what those look like. We're just going to jump into this and solve it, okay? So remember, the first thing is, what is the characteristic equation? And that's found just by replacing the y with e to the rt and all of that. So what do I end up getting at the end of the day? I get an r squared plus 6r plus 9. That's equal to 0. How does that factor? Well, it's the section on repeated roots. So this is r plus 3 squared is equal to 0. So that tells me r is minus 3 and minus 3. Okay, now remember, I can't simply just say e to the negative 3t and e to the negative 3t are my linearly independent solutions, because they're literally the same. They're not linearly independent. They're scalar multiples of each other. 1 times itself. Okay? So my solutions are going to look like what? They're going to look like e to the minus 3t, and then I'm going to have t e to the minus 3t. Okay? So if you're like, whoa, where's that coming from? Check out the video on repeated roots for second order constant coefficient linear homogeneous ODEs, and you'll see how I derive that's a solution to the corresponding ODE. And it's linearly independent from e to the negative 3t. Okay, so the moral of the story is, look, if you have repeated roots, you're going to get e to one of the roots and then t times e to that same thing, and then you just keep multiplying by t to get more linearly independent solutions. Okay, so then what's my general solution? The general solution is, again, remember, y sub h just stands for y homogeneous because it's a homogeneous ODE. When we talk about non-homogeneous, you'll see that I'll notate things a little differently, okay? But y sub h of t, just take a linear combination of these. So that's c1 e to the minus 3t plus c2 t e to the minus 3t. If you want, you could factor out an e to the negative 3t. It doesn't matter. But at the end of the day, there's your solution to your, wait for it, constant coefficient, linear, second order, homogeneous differential equation with repeated roots. Okay, so hopefully this helps you get a better feeling for how to solve these. The methodology is the same for all of these, including when you increase the order of the ODE. Okay, so again, like, subscribe, all the good things, comment down below, share with your friends, and we'll keep moving.